This is the FRC Roundtable, coming to you all the way from Minnesota. Your host team 2052 KnightKrawler presents this weekly FRC gathering where FIRST robotics competition teams take cooperation off the field. Share your knowledge, give and get advice, solve a challenge, or celebrate what makes your team special. 3, 2, 1, go!
Welcome, everyone, to the Sunday night FRC Roundtable. My name is Scott Davis. I'm a mentor for Team 2052 KnightKrawler. Kevin, you want to introduce yourself?
I'm Kevin Wynn. I'm the build captain from 2052 KnightKrawler. I'm a senior.
So tonight we're going to have a great conversation about CAD, and we're going to see some CAD show and tell. But before we get started, a few little housekeeping notes here. The FRC Roundtable is recorded for YouTube and Spotify. You must be 13 years old or older to participate on the live call. If you are comfortable, we ask you to please have your cameras on while you're speaking. The Roundtable is no longer exclusive to Minnesota teams. Mentors and students from all FRC teams are welcome to join us. And to find more information, including our complete privacy policy, please visit team2052.com/roundtable. With that, normally we would have a What's on the Wiki topic, and we're going to do the topic, but unfortunately it is not on the wiki yet. So let me share my screen. Kevin, if you can stop your share, I'll start mine. And I need to present this thing. Here we go. Tonight's topic is going to be our caster chassis. Can you all see that? Is that up? Anybody give me a thumbs up here? Are you able to see my screen? Okay, so Kevin says thumbs up. So one of the things that we did this year that's new for our team is we tried to create a prototyping chassis. And we did that by making it with 2-inch casters, and we CNC'd out some 3/4-inch plywood that represents our MK5 modules. And then in addition to that, modeled some tops that are the exact same size and dimensions of the MK5 modules that can go in every corner, so that we can build whatever prototypes we want on this chassis without taking the actual driving chassis away from our programming team or anyone else who might need it. And we ended up doing our rebuild. So this is our second robot this year, and we did our rebuild on that caster chassis. So it worked out pretty well. I think we're going to probably use this going forward. And Kevin, if you want, I'll stop my share. If you want to show the CAD of that quick, we can show where that CAD. And I will have all of this on the wiki, hopefully within a week. And so you'll be able to go to team2052.com/wiki, and you'll be able to take a look at the model, download the parts if you want to 3D print or get measurements or cut them out on your CNC. So yeah, that's our caster chassis. We call it Cassie. And so we use Cassie this year to prototype our second robot, which I'm sure Kevin will go through tonight. Mm-hmm. All right, with that, Kevin, the floor is yours. Take it away.
Yeah, let me just pull up my slide deck. Okie doke. So as like the roundtable title suggests, we're going to be talking a lot about document organization today. What we used to do, what we do now on KnightKrawler. Some kind of like more key aspects of it. I won't go like fully in detail of what like top-down design or top-down organization is because so many other FRC teams already use it. There's a lot of really nice materials on it, tutorials on it through like frcdesign.org and through other Chief Delphi posts. And then so after we go through over like the really quick summary and really quick overview, we'll then go to like a demo on how it's used and what it actually looks like in practice. And then we'll go through like a CAD walkthrough of our robot this year. So some kind of like background information as to why we switched over to this this style of CAD. Before, we use something called single document organization, and what that is what it sounds like, right? So you put everything for for your full robot into one document. So that means you have your master sketches, your full fidelity parts, all your mechanisms, all your assemblies in that one document. There's a lot of like pros and cons that come with this, right? So obviously, um, it's a lot like simpler, right? You only have one document to look for, right? If you need to integrate like your shooter into your intake, you could just switch over to your intake, make sure there's no interferences, and then go back to your shooter, right? And then you could also take full advantage of like in context sketches because you have everything in that one document. And then there's also a lot of obvious cons. You have performance issues because you have all your features in that one document, right? So that bogs down like iteration. It takes a lot longer to create a new part studio and therefore create new parts. Um, you also have like team collaboration issues, and this goes into like the next point. But let's say fictional person Jimmy, he's working on the intake and I'm working on the shooter, right? Um, let's say for the shooter, I need to figure out what the ball path from the intake to the shooter is going to look like. Um, so to do that, I'll have to make like an in-context sketch or derive Jimmy's intake into my document so I can make that ball path, right? But by doing that, I'm directly linking my shooter part studio to his intake part studio, and therefore, when he makes like a change to the intake, that immediately makes a change to the shooter. So this becomes a problem where when let's say we're working on it at different times, right? Jimmy makes a change at like 6 p.m. and then I go to work on my shooter at like 8 p.m. or something, right? Um, if he makes that change without telling me, it could break my shooter CAD, and therefore I have no idea why it's broken. So I have to go in, look for what the change is, and then figure out how to fix my CAD from there. And then there's a lot of like other mistakes that could happen with that. Um, your part could change just like slightly, and then you don't notice it, or you end up making your shooter right, and then it all breaks. So the way we go about, or the way we fix this is by splitting our robot into multiple different documents, specifically through something called top-down design. So top-down design is exactly what it sounds like, right? It's splitting the robot into multiple different documents, typically by subsystem. And again, there's a lot of pros and cons with this system. The main pros is that it fixes your performance issues, or at least helps it, because you don't have all your features in one document. And then it also helps with team collaboration, right? Instead of Jimmy's changes to the intake immediately affecting my shooter, he either has to update it for the changes to happen, or I have to pull it from his intake. And then that makes it so any changes that happen are intentional, and I, as the person making the intake or making the shooter, um, is able to view that change and fix it more on the spot. So it's a more controllable environment. But a con with this is that there's like harder integration. And what I mean by that is more so like um, there's a lot more like systematic integration that you have to do to make top-down design work. So what I mean by that is that the way top-down design handles like packaging and having multiple mechanisms, because all your documents are split, is by making something called like a framework document. There's a lot of different ways to build a framework document. The most common way is like through master sketches. We'll go through like 2 different ways you could do that, including master sketches in a second here. But a framework document basically lays out the conceptual idea of your robot before you commit to it. So you build like, let's say you get your game right. You say, I want to build like a turret robot with a spin dexter and like a link take, right? You could design and figure out what needs to go in there, and kind of figure out like the packaging aspect of it before you commit and build the subsystems, right? Um, and then the other like kind of pro with this is that let's go back to like the Jimmy example. Um, when he's making the intake, right, he derives it off of the framework document, right? he derives the sketches or whatever parts, composite parts, etc., that comes from that framework document into his document, right? And what this means is that my shooter is no longer linked to his intake document part studios, right? So the main way like you see the advantage of this is, let's say you need to make like a massive change to the intake. You need to go from like just a simple fold out rotational intake to like a four bar or like um a intake or whatever, right? Instead of just breaking all your subsystems because everything depends on like the intake or something like that, right? You change it in your framework document, and then that change is compartmentalized to just the intake because the intake has a separate sketch in the framework document. Um, this lets me, right? Let's say I'm working on the shooter, um, not have to change my shooter part seals or my shooter document because a massive change happened to the intake. Um, yeah, okay. That was a lot of information. Before I move on, are there any questions about that general overview? Oh,
Yeah, I put a comment in the chat to say that versioning actually is a little bit easier, because if you version your component or your subsystem, the whole robot version doesn't change. So if you're working on something that somebody versions, and all of a sudden, if it's one single document, all your changes are version 2.
yeah. Yeah, along those lines, it also makes like branching a lot easier and like making different versions of a mechanism easier. So if you have like two different intake designs, you can make a branch within the intake document instead of making a branch within like the for robot document. And then that also makes merging it a lot easier too. Yeah, versioning becomes less of a headache. All right. Is there anything else?
Kevin, so I'm curious on that. So let's say you put a lot of time into the intake this year. Is that correct?
Mhm.
Like how many people would have worked with you on the intake, or were other catters working on other aspects of the robot while you focused on the intake? And then like when you would version that out, is it like Kevin's version and Steve's version, or Kevin's version 1 and Kevin's version 2, as I'm thinking of another way to do this, so on and so forth?
Yeah, that's a interesting question. Well, this year we didn't encounter that problem because we have a smaller cat team, and therefore we're able to communicate our changes together. But ideally, how it would work is that you'd figure out like which design you'd be going with based on like prototyping and whatnot, and then only have that be merged into the main document if that makes sense. So you can still make like two subsystems in parallel and test them in the robot. And I'll show that a little bit in like the demo, in terms of like how to add different subsystems into the main document and like look between them. Um, but yeah, you shouldn't necessarily encounter an issue where you have two different conflicting versions.
Okay, thank you.
Okay, is there anything else? Right. So a little bit more into like what those framework documents look like, and like the specifics in terms within them. Like the easiest way to make a framework document is through like master sketches, right? And what master sketches are, they're detailed sketches containing major dimensions of a mechanism. So this includes your gears, your pulleys, your wheels, your game piece path, anything that makes anything that you need to visualize your mechanism properly, and anything that you need to make a plate out of your mechanism. Um, so some key like things about this is that you need like a different sketch for every mechanism because, like I said previously, when when or if you have to make like a major change to one mechanism, you don't want that master sketch to affect other master sketches or affect other part studios. So you have that layer of separation. And then there's also like different levels of complexity when it comes to a framework document. So you can kind of see in like this this one, right? It's all kind of layered in like a 2D format. While on the right, this is from Mechanical Advantage. It's more so in like a 2.5D layout where you get like actual depth within the robot. And this is kind of like the con with master sketches too. It's really hard to determine depth and determine like true dimensions within your master sketches, um, because everything is 2D, right? And a way to get around that is through blockad, or specifically like high fidelity blockad. What this is it's a derivative of blockad that includes like more, I guess, like simplified but also finalized versions of mechanisms, so you can visualize that 3D format. It front loads a lot of the robot design, which allows you later on your CAD process to only focus on making the plates as well as they can be, right? And you don't have to worry necessarily about if a part interferes with another part, because you've already figured that out um, within the blockhead, right? Um, so in this, you model all of the translational geometry along with the main mechanisms. So basically, you do everything that you would do in a master sketch, right? You have master sketches still, but you add another layer onto that in actually creating a 3D format of your robot. Um, so yeah, like the major pros of this is that you get the concept of the robot early. So therefore, if you need to communicate this to the team, right, communicate design or communicate where robot design is heading, you could show your block CAD, and it's pretty easy. It's pretty easy to visualize what the robot's going to look like at the end. So everybody's on the same page. It also makes like when you make the final mechanisms a lot easier, because you just derive it and extrude it off directly, directly off the blockhead, um, which again smooths the process, makes everything a lot easier, but then it also like takes a lot more time, of course, right? So there's pros and cons with both of these methods. um, yeah, I kind of went over these while explaining the other um, advantages, right? But this is kind of like a really fast and really summarized overview of what top-down design is, how to do it, um, and like the pros and cons with it. Again, there's a lot of other resources that I could share in terms of the specifics, right? And more of like how to do it well. But I'm not going to go over that now because those resources exist. Unless people have questions about it. All right. Are there any questions or comments concerning that bit? Okay, doke. So now I'm just gonna do like a quick little overview, or like a quick demo on how it works. Um, so I'm gonna do this based on the master sketch that we've already made for the version 1 of a robot. So open this a new tab and then go in here. So let's say like we've gone through the block CAD, we've gone through the master sketches, right? And now we want to make the actual mechanisms, right? Um, you would have a different document for each mechanism. Let's make this one like the chassis. Um, so this is, I guess, like going over like the block CAD version of how you would go about starting your final mechanism documents. So the first thing is creating an origin cube. Essentially, what an origin cube is a parametric way to keep the center of the robot throughout all your documents, right? So that way, when you create like your full robot document, right, you only have 4 main features. Everything is where it's supposed to be, because everything is based off of that one origin cube. But yeah, you create your origin cube and you kind of go through this like the same setup process that you would go through throughout all of your different documents. So you go drive your drive in CAD. And then there's a lot of different ways to like derive based on how much you want to make within your like mechanism document versus how much you want to keep within your driving CAD. The way this is set up is where most of the parts is in the driving CAD itself, right? So I'll derive this. This has all the blocky features, right? But we can't have that in a robot document, right? So go make a folder called setup or something, put that in there. And then this is what makes, I thought I had that. Okay, whatever. This is what makes kind of blockhead easier, right? You extrude directly off of these blocks to make things like plates or framing. So go ahead and doing that. Could then hide this, and all we need to do is create a tube. And this is going to take a little bit. Then we'll make another tube conversion for these 1x1s. Make this like 16th wall. Then go over here and make the cutouts for your modules. And like you could kind of see how making all these decisions of like where these frame rails go, how all these are laid out and relative to each other beforehand makes the process of making like a final mechanism or final part easier and faster. So go out like that. I need to take this, figure this out, change this. Then you make like a little square. Okay. Okie doke. Then, oh, I need to add that too. Whoops. Remove all this. And then, yep, that's it. I have my frame. If I want to, I can add the belly pan, but just for the sake of these purposes or this test, we'll just keep it as just these frame rails. And then my assembly, I'll just insert everything as one part studio, do that, mate these together. And then all I need to do is add my modules, and then I'll have a chassis assembly to work with. So add these in here. Which one did I make? That one. Make sure that thing goes here. Make a copy of this. Change the configuration of this to match the side. Oh. And then I could just do assembly mirror to make these modules on the other side. Or we could do a circular pattern. So the axis there. Okie doke. And now we have our chassis assembly. Name this chassis, right? And then in my main robot document, we go over there. This is going to be the full Roundtable robot. I can insert this into here and then have my full robot assembly in this document. So go over, take this, create a version here. It's gonna take a little bit to get. Take this, plop it in here, make this the origin, and now I have a chassis in my full robot document. And then you basically just repeat the same steps for all of your other mechanisms, and then you insert them in the same way here. So kind of like as an example, we'll take, let's say, our intake from V2. We'll steal this guy, pop in here, and then do kind of like the same thing. You make this the origin, and this is what makes the origin cube really nice, because again, it keeps everything parametric. This intake is exactly where it's supposed to be, and assuming that you repeat the same steps for like the driving CAD to make that parametric to the intake, right? Everything should stay in relation to each other without having to do separate mates and fastens. And then this works. Another thing that's good practice is to set up Robot Manager. So what Robot Manager is, it basically manages your robot. So it handles like all the versioning and all the merging of all the different documents into this, right? So that way, let's say if I make a change to the chassis, if I wanted to, for some reason, take away this chamfer, right? Instead of having to make a version, right, and then update the version over here, all I need to do is click this, click push version. Oh, I need to make this a parent document. Oops. Do that. Close. We could click push, and then it'll update this not hit chamfer to this once this push finishes. This is also really nice for if you make like a manufacturing document. So that way, if you make an update to the mechanism, right, whoever is cutting your parts or whoever is like setting it up doesn't need to manually version their manufacturing document, right? So here you could see that that is no longer chamfered, and then everything here is updated. So yeah, that's a quick little demo on how this works. Is there any questions on that?
Yeah, I was gonna ask, have you seen any downsides to using the Robot Manager app?
Yeah, sometimes it like, so my understanding of how it works is that it uses like a separate server to manage your documents. So like sometimes there's cases where if you push or if you pull, it just doesn't and fails unexpectedly. But then if you manually make a version and then you push after, it works, right? So there's some annoyances there, but other than that, I haven't necessarily like seen a glaring issue with it. Yeah.
Cool. Yeah, that's totally new to me. So yeah, thanks for sharing. Awesome.
Mhm. Is there anything else?
Kevin, the origin cube is super critical to making all this work very smoothly. What tips do you have in terms of positioning, for example, this intake correctly so that when you drop in the origin cubes, the holes all line up in the frame and things like that?
Mm. Yeah, so that kind of all boils down to how you make your setup. So let's just go to like a different random part studio here. Let's go to a rolling floor because it has the best performance, but it should take the shortest time to load. But we go here. This orange cube is the first thing that happens in this, right? And then everything in the kind of like this master sketch here is based off that origin cube, right? So let's go to this link document if it allows me to go there. Open link document. This is the driving CAD for our second version 2 robot. It uses master sketches because it's mainly a 2D robot, right? It's just like a full width bar. There's nothing like in the middle to necessarily like block out. So most of it is a 2D sketch. So as you can see, like the origin cube exists here, right? Everything is in relative to that origin, and that origin represents the bottom of the robot. So making sure like all the holes align and everything fits right all boils down to how you use your kind of like your setup document or like your master sketches or your block CAD. And then also making sure you set that up in your part studios and then relating it correctly in your assemblies. Kind of like the most common failure point probably is when you add your plates to your assembly. A really nice feature OnShape has is to like insert parts of part studios as origin. That's what I did in this chassis version. You can see it here, right? The part studio kind of has like those lines around it that represents that this is a rigid part. And basically what that means is that anything within the part studio is treated as just like one assembly instance. So if we get that back, everything here is just one part. But if you have something like this, where I didn't like actually make the full rolling floor in this part studio, right? There's no other plate. All these belts are just kind of like floating here. Another way to do it is if you just insert, let's say I want to have this in the origin cube, right? If you insert those together, they will be in relation to each other, and you just need to make sure that before you move anything, you do a group mate. So then OnShape basically does the same thing as if you treat or if you create an origin and treats it as one assembly instance. Is there anything else?
Kevin, if there aren't any questions, could you give us 10 minutes or so looking at the robot version 1 and robot version 2, and then we'll move on to having anyone else who wants to show their CAD doing their demo?
Yeah. So, well, I guess I should start with version 1 of the robot. Let me see if I can find it. So here it is. This is version 1 of the robot. The CAD's not necessarily updated to the state that we had it for like North Star, right? So it doesn't have all the random parts on it. Oh, I also need to update this. Oh, this is also a really nice feature with Robot Manager. It has like an update all feature. OnShape also has it up here, but this makes it so all your references that you intentionally linked in your document. So let's say like all the random hardware and stuff that FRC design has. OnShape, clicking this will update just everything, right? And like this random stuff pops up. You have to go through all this, right? Robot Manager just updates all the references that you link in Robot Manager, and this is because I deleted a parent document, but that's separate. But yeah, that's also a nice feature Robot Manager has. But here is our robot. I will show our bumpers. We have our forward bar that is here. It has 2 gearbox plates on either side, and it's coaxially driven. So this is one of the pivot bars that go across. The plate that rotates on it has a bearing, so that when the shaft rotates, it doesn't actually rotate this plate. And what that allows us to do, it allows us to drive different belts up and power the rollers. Also has a through-bore encoder on this side. This is like a little custom through-bore encoder that we made over the summer. It's inspired by Elliot's design. Elliot's a student from Wildstang, and he made a through-bore encoder, I think maybe 1 or 2 years ago. So this is just a version, or like an improved version on it, that doesn't use like bearings. So everything here is printed, and it has a better like can holder, or like a more intentional can holder. So we have that there, and then it folds in and out. Moving on, we have our spin decks here. This doesn't have the changes that we made to it, but in the actual robot, we have a rolling floor on it. So originally we designed the Spindexer to be like a brush Spindexer, kind of like what Rembrandt's had early on in the season. But after it didn't meet our BPS expectations, we switched to a rolling floor. And that change was kind of on the fly, and that's why it's not in the full robot CAD. But that Spindexer goes into our stager, and then into our turret. And then this has a rotation, and then also has 2 more through-bore encoders on the bottom here, that are also custom made. These are hex through-bores as opposed to the spline through-bores we showed before. But this allows for CRT on the turret because our turret had a greater than 360-degree range of rotation. And then we have our hood, which is here. And it has a herringbone gear that powers it, and then this printed kind of like hood back piece that we have. So yeah, that's version 1 of our robot. Are there any questions on that? Okie doke. So moving on to version 2, the main changes here is, well, everything basically changed except the intake. Though the intake did have a couple of changes. So starting here again, right? It's still like the same plates, the same 4 or 6 bar action. That's odd. Okay. But it still has the same 6 bar action. And then the biggest change here is how the gearbox is made. It's still like coaxially driven. Still has 2 motors running the rollers, but it only has 1 motor running the pivot portion of it, and then we could just isolate this. It has a jack shaft running through, and then is also a lot thinner than original intake. And the reason for this, I could show the difference here. That's how thick that was, and then this is how thick this is. So it's about like 1 or 2 inches thinner. And then the reason for this is that to make our drum effective, we wanted to make sure that it could shoot as many balls at once as possible. So by thinning our intake plates, we were able to fit around 3.5 balls between both of our plates. So after that, we have a rolling floor, which is powered by two X44s here on the bottom. It has a 1:2 gear ratio, and then that feeds into our shooter, or kind of like the shooter tower. It has like a ton of like gearboxes on the back. It has, I think, 7 motors in total. 4 shooting motors, 2 stagers, and then 1 hood. So we have this 3-inch roller, which is geared to one of the motors here. And then we have another motor running kind of like this back set of wheels. We originally tried to gear, and it's not updated in the CAD, but we originally tried to gear this so the surface speeds of each individual roller in the stager would match. And then throughout the robot, the surface speed of each roller would slowly increase over time. But because we needed more torque, we kind of ditched that notion, although it still kind of exists, right? The surface speeds between this roller and the back rollers no longer match, but the surface speeds in general do slowly increase over time. So that was the design intention here. And then we have our hood. It has 4 motors powering it. So this motor is bolted to this motor, which is bolted to the shaft that runs all the way across. And then these 2 motors are bolted together and then is bolted to a flywheel that is hidden over here. This motor? No. Well, it's somewhere here. Oh, here it is. Yeah. So it's bolted to this flywheel, 1 to 2. So this flywheel spins twice as fast as our drum, which gives us more inertia. And then after that flywheel, it's bolted to the shooter up here. We also just like we originated with a kind of expanding hopper idea, which is somewhere back here. But we originated with an expanding hopper, and then we switched to a rotationally expanding hopper because of weight. And then we realized that our intake couldn't actually keep up with the amount of capacity that would expand. So we just ended up with a net, which is also not shown in the CAD here because it's a semi-recent change. But this is our idea for the rotational hopper. It would just be 2 sticks with a net going across that would connect to the intake. Yeah. Is there anything that people have questions about?
Yeah, so I was just wondering for like belting and flywheels and whatnot, like how much of that is calculation based and like just designed into the robot versus how much of it is just like put it on the robot and then if you need a bigger gear ratio or a different belt ratio, you just change it on the fly.
Yeah, a lot of it's like a combination of like prototyping, what we see from open alliances, and what we calculate. So in terms of like calculations, we did a lot of like flywheel calculations. We use a website called Recalc. There is a flywheel calculator here that you could set up. It has like all your shooter properties, MOI, and custom MOIs. So we use this to determine our flywheel, or the amount of MOI that we had on our shooter, and then determining how much MOI we needed was found through just like looking at other teams. So we saw that like Mechanical Advantage had about 20-ish MOI, I think, if I remember correctly, or maybe more. So we aimed to get to that level. And then something neat about OnShape is that if you assign materials and then assign other properties, it gives you the moment of inertia of like a flywheel or of your tube roller, right? So this is how we determined how much MOI we actually had within the system. And then in terms of the gear ratios, it's the same thing. We figure out like how much we think we need and like take a guess, go through prototyping, and depending on what prototyping like shows us, we either add more ratio or less ratio, or we again look at other teams on open lines, see what they have, right? Try it out for ourselves, and then change it based on that.
When you're prototyping that stuff out, are you then, because you already have it in CAD, are you making it out of like plywood or something that's CNC cut, or are you putting them right to metal?
Yeah, so we have a laser cutter in our school. Our mentor Nate knows how to use it. So when we do make a prototype, I can actually pull up a prototyping document. If I could find one, question mark. Oh yeah, here it is. So when we make a prototype, let's say, which one's a good one? Here. We go and just like make a sketch of it and then export it as a DXF. So you can kind of see like Nate export this. There is a thing here, right? So we have like plate sketches, and then we have like a final plate sketch, right? Which has all the holes, all the plate geometry that we need. And then we export this as a DXF, and then we send it to a laser cutter, and then laser cuts it out of just plywood for us. That's a semi-new addition that we added to our prototyping process this year, and it's worked really well.
And we use 1/4-inch plywood, and then we double up the sheets usually.
You mean 1/8 inch?
1/8 inch. Yeah, underlayment basically, that you can buy in 4x8 sheets.
Okay, thank you for that. I guess a follow-up question would be then, like, how much CAD is done right off the get-go? Like, what is the time frame? Like, and then how much, like, is that students, or are there mentors following along, kind of checking as it goes, or how much mentor assistance is going with that, or like what is the CAD deadline, I guess, so you can get a robot for week 1, because you guys competed obviously week 1.
Yeah, I'd say like this year is somewhat different from previous years in the fact that we went a lot more CAD heavy. So with our new laser cutter, we just like usually we start with like 80-20 prototypes. So we assemble like a frame, and then just slide like prototyping blocks on 80-20 bars to figure out like different compressions, and then turn that into CAD. But this year we did a lot of CAD first. So like all of this block, this where is V1? But all the block for V1 was done within, I think, the first 2 or 3 weeks. And that like 2 or 3 week process was or like after week 1, most of the CAD done was mostly just figuring out like where, or like specifics in terms of like, oh, we just need to touch up the intake, or oh, we just need to figure out like what we can do for the turret ring. But like we were able to figure out most of our like main documents by, I'd say, like end of week 2, start of week 3, and then we started manufacturing around week 4.
Pat,
What was the workforce, I guess, on that? How many kids, mentors, as a, you said you have a smaller CAD team this year. I'm just curious, like, I'm looking at this CAD, I'm like, we're nowhere even close to like making such a thing happen. I'm just curious on how many people contribute, or hours or something.
We have about like, I'd say 2 to 4 people on our CAD team, and a lot of the CAD was made by students. So yeah, a lot of it was made by students, and the way like mentors got involved was mostly by double checking. So we'd make a design, send it to like the design channel, be like, hey, is there anyone that could look over this, or I have a question about this, or like the intake needs to go in, but it hits this. Does anyone have any other ideas on it? And then the mentors would give feedback. Another way mentors got involved was by guiding like newer CAD students in making mechanisms. So I don't think it's shown here, but our climber this year was all done by new CAD students. Scott could talk more about it because he was the mentor that worked with them on it. But that's another way mentors got involved. Otherwise, it's almost all student led.
That's awesome.
Pat, Kevin's being a little too modest here. 80 to 90% of what you saw was probably the final designs were done by Kevin. Other students may have been involved in some of the initial block sketches and stuff. And Kevin's doesn't sleep. So, this is 100 hours in 2 weeks, most likely. And that may or may not be an exaggeration. So
Well, can I
we're
pause
very
for a second, Scott?
Yeah.
That's what I was curious on, because this was one of our biggest questions as a team, when we're literally been asking some of the teams that have had amazing CAD, and it's how does it get done? How does it get done? And what we're finding out is there is one or two champion CADers, probably one, and they put in 80 hours in that first small window of time to make it happen. And that's kind of what I'm finding, is that seems to be more of a norm than an outlier.
Yeah, I agree. And that's the way it's been on our team for the last couple of years. It's not the goal. The goal is always to have more students involved. But I think the same is probably true for the programming team, is there's only so much you can accomplish during a meeting, especially when there's distractions everywhere. To really be able to get heads down into the code or into the CAD, it takes students that are putting in extra initiative to get it done. We're going to miss Kevin next year when he graduates. We're really going to have to make it a much more group effort with the students that will follow behind Kevin. But it is true that, just like if you have awesome autonomous or awesome vision code or whatever it might be, oftentimes it's one or two students that are putting in a lot of extra work to get it done.
Okay,
Yeah.
thank you for that.
Just to add on, yeah, I feel like this is a norm for most teams. I mean, it's not a good norm, but it is a norm. And going into the season, we wanted to kind of find a way because it's hard to make a robot and have the integration within a robot when you collaborate, just because you have to figure out, or you have to make sure everybody understands that, hey, when the intake goes in, it will interfere, or it will cover this much area, right? So you can't put anything in the area. So it's difficult to create integration that way. So Block CAD was supposed to be a way to allow more students and more people to work on CAD, because I would make the block CAD, make sure nothing interferes, and make sure everything integrates in that way, and then send it off so people could just extrude the parts, right? Work on making the final plates. But it's difficult to really make that work with the time constraints you have, right? And then also making sure everybody understands the design before they make the full parts.
Kevin, you obviously have a ton of skills. Can you tell us a little bit about your background? How did you develop these skills?
Yeah, so I think I have a more interesting pathway to CAD in terms of I was not a CAD student first. So a lot of my background comes from being a build student. I've been on the team for 5 years, so I was able to get really, really early experience in terms of how robot building works, right? Water motors, how to use motors, gear ratios, wheel types, when to use different wheel types, compressions, etc. Right? So having the background knowledge coming into CAD made learning CAD a lot easier, because I didn't need to focus on how FRC robots work, and just focus on how to use OnShape. So that made it a lot easier for me. And then also, I only really started using CAD my junior and sophomore year. I used it a lot in my junior year and became one of the main team CADers my junior year. But my sophomore year, I only did one mechanism on the robot, right? And then I started learning my freshman year. Yeah.
I will say that what we've learned last year and this year with Kevin doing a lot of the CAD is that we need to start CAD much sooner. And when I say much sooner, I'm pushing for October with our students. We didn't do that the last 2 years. We waited until December before we started really trying to introduce CAD to students, and it's just way too late for them to contribute in any meaningful way on the robot. The discussions that are happening right now on the team is that students are working through the OnShape lessons and the FRC design lessons now. Lots of kind of thoughts about we really need to improve our CAD skills this summer. And so I think it's really interesting that the students are seeing what Kevin has done. Kevin and a few of the other students have done with this. They want to be part of that. And we're not talking about learning CAD next November. We're talking about learning CAD in April and May. So I'm optimistic that we have big shoes to fill when Kevin leaves. And we had that 2 years ago when Isaac Johnson was doing all of our CAD, or I should say most of our CAD. And then we did a little bit of role reversal, and Kevin did all the CAD, and Isaac did a lot of the build. He did a lot of actually the fabrication on the CNC. We have not done a good job of sort of setting up that transition after Kevin leaves, other than to say that we have a lot of students excited for it. And I think next year will be a much more collaborative experience with more students. But we're optimistic that we can fill those shoes quickly. Maybe that's the best way to say it.
Thank you,
Yeah.
Scott and Kevin. So when you talk about, developing those skills in the summer and the fall, is that kind of working independent alongside each other? Do you have a formal system for developing those skills, or how do you manage that?
Kevin's waiting for me to say stuff. We send them through the basics, OnShape training, FRC design training, and those things. We have not developed a formal system. We've spent years building what I would say pretty good programming training, saying if do this, very sequential type of training that we've run our programmers through. And I'm optimistic that we can start building that same type of thing this summer, this fall with our students. Personally, I think the way to do that is to take a robot and redesign something that we've already done or do something similar. Another thing that we may get some traction on is that we have four XRP robots, and a few of our students last summer designed an XRP game. So full game manual, field layout, scoring objectives and everything, with the goal of we wanted our build students to learn CAD so they can 3D print parts that could go in the XRP robots that would be driven. You get 2 motors and 2 servos as extra mechanism components on an XRP robot. So the idea being that they could CAD and then 3D print a mechanism to, we designed a game with wiffle ball golf balls so that you could move those balls around the field and score them with XRPs. And then that would also give our programmers an opportunity to control those mechanisms and build autos using XRPs. It sounds like, oh, that's great. Yeah, let's do that. But it actually ends up taking months of working through what would the objectives be? How do we guide students to do that? So we may get some students that'll hop into CAD because they want to learn to 3D print. They want to design for 3D print. But we may also just have students that want to say, hey, I want to figure out how to make a different kind of intake for Monarch, which was this year's robot. And maybe that's where we'll start. I don't have the answers to those things yet. And I think it's really going to be up to our new build captain, which we select after state. And they work through the summer. And I think it's going to be up to our new build captain. And if we have a CAD leader, those two will have to decide how we want to try to approach CAD training.
Just to add on, I think after just understanding OnShape and understanding robot mechanisms, the biggest way I improved as a CADer was by paying more attention to Chief Delphi and joining something called DDS, which is David's design server, and learning from other teams in terms of the different techniques they use or the different ways they design. There's this, it's no longer on the robot, but there's this slot and then these 2 holes here. That was originally for a cam tensioning system for a chain, right? And then I learned all that by looking at, I think it was Jack in the Box 2023 robot. Spectrum released like a design walkthrough, right? So just watching that video, understanding the different ways they design, and then the different reasons as to why the design parts the way they do, um, gave me like more options when designing like this robot. So those resources are also a big thing to look for.
Okay, we have reached the 8 o'clock point. I'd like to make sure everyone else has a chance to share. So can I call for any final questions for Kevin? And we can circle back if we run out of robot demos, but I really want to make sure all the other folks that are here to show their CAD have an opportunity to do that. So one last question, any final calls for Kevin? All right. So who wants to go first? I know that we have, I think 4, maybe 5 students who are on the call to share their CAD. So anybody want to go first? All right, Daryl, it's all you. Go ahead.
All right. Can you guys hear me?
Yes.
Okay.
Can't see your screen yet though.
I haven't done this in a while. I think this will. Okay.
Yep. There we go. It looks great.
So here is our kind of main CAD of our robot. We kind of put every subsystem kind of came here. So we have our intake was in its own folder down here. Our shooter was, our hopper. So I guess the way we kind of did it was we had, I think, 2 students work on the shooter. I worked on the intake, and then we had 2 students working on our hopper. We also had a climber, but we decided not to do that. So we kind of did, so this is kind of the intake part, and it has all the things entered in and all the fasteners and whatever. And then we entered this whole thing into the main assembly so that it didn't get crowded. So it's kind of the same with our hopper. The belt, we have the problem was that I was the design lead, and I just learned design this past summer. So we didn't have much of a structure to go off of. But so we kind of just had to work with whatever we could find. So our main objective was a big hopper. So there's actually a piece of polycarb that kind of goes right here to make sure that the balls don't go into this corner that we never entered in, because we just had to fabricate that on the fly. But yeah, and then I guess all our electronics are on the bottom. This is what we've been doing for the past couple of years. It's really helped us with space on the top. And then we have a polycarb, what we call belly pan, that goes right on top of it or underneath of it to protect it. And we've been beached on balls numerous times, and it hasn't ripped out any wires. So yeah, I don't think there's much else. It's kind of boring, not much going on.
Daryl, I love how this big belt system into your shooter is recessed below the floor. That was a surprise to me. I think that's awesome that you put that hole in your belly pan to expose the top of that belt. That's really cool.
Yeah, and they actually have bumps on them, and it was 3 printed in 3 different parts, and then we PVC. I think we used PVC cement glue to glue them all together, and it didn't break at all. So, but yeah, it's a pretty cool part that one of our new designers made.
So how many students did you say that you had working on this?
We had 1, 2, 3, 6 to 7, I think. I'm pretty happy with that because the last, 3, 4 years, it's been one person, and he graduated last year. And then I realized no one else knows how to design. So I had to learn this past summer how to design, and kind of work through it. We did um, mini trials for our preseason, and that helped, I think, a lot with it. But yeah, it's just been a roller coaster, I guess, going from 1 to 7 people working on it.
And then what were your individual components that you broke up your students into?
So I worked on the intake. We had 2 students working on our shooter. The turret we pre-bought, so they kind of worked on that. The person who did the shooter also did the feeder and this kind of small ramp here. And then 2 people worked on all the polycarb swerve drive covers, the belt here. And then we had, I think it was one person that designed our climber was going to go here in this spot. We ended up not doing it because we were at, I think, 114 before we put the climber on, and we're like, we don't want to shave 5 pounds off. And then we all kind of did these like camera mounts, these small camera mounts, this swerve drive cover. We kind of all chipped in with that. So
Excellent. All right. Thank you so much, Daryl.
yeah.
Any other questions for Dale? Go ahead, Brad.
Yeah, I have a question for Daryl. Also for Kevin or whoever else can chip in, but you talked a little bit about weight. I was wondering, like, how much do you deal with assigning individual material properties and like making sure that what your CAD weighs is actually representative of what your robot will weigh or stuff like that?
Yeah, I can just answer first. The whole intake, and I think that was all polycarb. We tried to use as little aluminum as we could. We had our kind of chassis drivetrain pre-built with all the electronics, so we knew what that was going to weigh. And I think that was 60 pounds. And so we just kind of slowly kept making sure, like, okay, we make the intake, we make the prototype, let's put it on our scale and make sure it's not too heavy. We make the shooter, put it on the scale. And then we kind of just did that over and over. I know that OnShape you can assign parts different materials, and then it'll add up the weight. I am not exactly a professional at that, so I want our team to do that next year. But kind of just using a lot of polycarb and aluminum tubing to make sure that we're not having any dead weight.
For KnightKrawler, we try to assign weight for everything. It was really important early on this season, when first designing the version 1 of a robot, to assign weights, because after making most of the parts except like the intake, we figured out through like the OnShape weight system that robot was going to be 80 pounds, which doesn't sound like a lot, but if you include like hardware and wiring into that, that's like 20 more pounds. So that's when we started doing like a lot more weight reduction things. We pocketed our belly pan, we pocketed our turret structure, right? Did everything that we could for those weight savings, and then we ended up at, I think, 105. So I think without those weight savings, we'd be at like 110, 113 ish, which would be bad because it wouldn't give us a lot of leeway. And then we also did a lot of weight this year and last year for a rebuild. So it was more important last year because we weren't doing like a full rebuild. But we did a lot of weight figuring to figure out how much weight we first needed to take off to put our ground intake on. That was the major addition. that we had from last year, and then also to put on our new arm. Um, so OnShape's weight figuring is really, really nice if you could use it. We don't do anything like fancy specifically. Like we just assign all aluminum parts as 6061, assign polycarb as just polycarb, right? And then assume that the weights are going to be close enough for it to work out. But just by doing that, it's really fast to assign weights. You could assign materials for multiple parts at once. But I guess like the rewards of doing so are great. And then it also helped with our MOI calculations, like I said before. So yep.
Okay. Let's move on. Thank you again, Daryl. Who else wants to go? All right. Briley, go right ahead.
Yeah, mine shouldn't take too long. I kind of have the bare minimum, I would say, for CAD. Hold on. Yes. Please let me share entire screen. There we go. I'll just kind of rip through. We went through kind of 3 designs this year. I'm the only CAD student. I learned CAD in the off season a little bit. I went through a 3-month internship with an engineering company, and so I'm using SolidWorks. Mainly we used CAD just to kind of get measurements. So most of it's like really simple stuff. This was our first robot. We started with a turret. We used some more 3D printed stuff. So these corner brackets are 3D printed. This intake for the slap down was 3D printed. We had some covers we did. And then we kind of moved into our second design, still trying 3D printed. This is where we broke our 3D printer. So we had to kind of account for that. And these ramps became plywood. So you can see here we have a drawing here that we used to get the sheet cut out for it with our laser cutter. But just really using that kind of, you guys call it the HFBC, the block catting, and that's kind of what we use it for, was just to get major measurements off of and to kind of get a general shape of this is what the robot's going to look like. And you can really see it in this one. I mean, we have big wheels, the side plates, and some design for the intake, but really simple stuff. It's kind of our walkthrough on our CAD. It's one person working on it, and because I'm also the main part of the build crew, most of my time goes into here's an idea and now I have to build it, and that takes a lot more time. So really simple stuff.
Bradley, has your team used CAD before? Have you always been a SolidWorks team?
This is our first year using it. And like I said, we use SolidWorks just because it's what I knew, sure, and I'm the one doing the CAD. Yep. We have not done CAD in the past.
So if you're planning to have multiple students on SolidWorks next year, when we used to do SolidWorks, we used GrabCAD to be able to share files. I don't know if SolidWorks has improved to the point where they have model sharing capabilities now, similar to how OnShape can allow multiple students into the same document. But something to look at over the summer is if you were planning to have a larger CAD team next year, figuring out how to share, how to have multiple students working on one document. That was a barrier for us in SolidWorks, but it's been so long since we did SolidWorks. I don't know what features are capable today.
Our team outlook in the future is we don't have a lot of bright stars, so we're just kind of we're having our run at champs this year, and then doing what we can, or looking to kind of prepare for what we can do next year is kind of where we're at. But it is definitely something that we want to look into if we had to do that going forward.
SolidWorks is an amazing tool, especially if you want to do really like stress analysis and stuff like that. I will say that when I switched from SolidWorks to OnShape, I just felt easier for me, and I feel like I was twice as fast. But SolidWorks is what the industry uses. I don't want to discourage anyone from using it, but it is a consideration for robotics teams, is what kind of hardware your students are going to have and how they're going to share. But anyway, nice job. We appreciate it. Thank you for sharing that, Briley. All right, who's up next? Who wants to go next? All right, there we go. Spencer, it's yours.
So unmute here. So yeah, kind of similar to what Briley's doing.
Spencer, we can't see yours. Oh, there we go. Now we can see it. Go ahead.
I'm actually a mentor for 5348, so I can't speak too much to it. But this is what we have. It's kind of just blocked out. Like I said, similar to what Briley was doing. The shooter was the one thing that we kind of really like took our time on and made sure that it was going to work, just because we'd never done a turreted shooter before. But other than that, yeah, it's really simple. I think Shooty can jump into here because he's the main coach. But I think we only had one student, maybe the equivalent of 1.5 students working on it, and between those students, 0 CAD experience before the season started. So yeah, kind of just an interesting thing to look at for the more experienced teams.
Yeah, this was done by one freshman that just loves CAD and he just loves it, but no real training. Spencer helped him a little bit over the off season, but he just dove in. All of our 3D printed stuff, I would say 90% probably CADed was from him. And then we have our main driver and one of our main build leads that knows CAD pretty well. Like he's quite talented, but he just doesn't have time to dive in and collaborate and not break things of the freshman students. So he just kind of was hands off on anything overall robot assembly. But then at some point, like the freshman also didn't know why he should keep doing the robot assembly because like the whole robot was done. So you know what I mean? Like it didn't make sense to like, why am I going back and like measuring old stuff to like update a CAD that we don't need updated for any reason? Like we're backwards, like we CAD after, where we really want to try to get to the point where we're obviously CADing first and then making parts and decisions from that CAD. So obviously like for us, we're in a different boat where like we kind of feel like the future's bright. Like we have a couple of young kids that really, really want to dive in and we don't know where to steer them in the right directions necessarily. That's why I was super excited, Scott, when you said that this was going to be your focus and knowing that Kevin was going to give a talk.
I think you might have been the one that messaged me and said, "Can we please do this?" Is that
I did?
Is that true? Yeah. So you're the reason why we have this talk. I will say your comment of we CAD after the fact. That's what KnightKrawler did. Basically the first 3 years we did CAD. We may have done we CADed obviously the plates that we wanted to cut on. At the time, the school had an X carve, so really lightweight CNC, and we did maybe 2 or 3 plates. But the CADing was usually done after the fact as sort of a project for a build student or just in case we needed to change something. We tried to keep the CAD as close to what the robot actually was. CAD first really is sort of a new post-COVID, maybe even a post-COVID type of revelation for KnightKrawler. So you guys are where, I mean, you got to start someplace, and CADing after the fact, not unreasonable. I mean, in fact, having a student look at it, that might be something that we end up doing this summer, is having a student look at a robot and say, CAD this mechanism that was built, and figure out how you would CAD it so they have something to reference instead of just using their imagination and coming up with something out of the blue. I'm not sure yet. We have not figured that part out. Okay. Anything else here, Spencer, before we move on? Oh, Jay's got a question. Or is it Jay? Do you want to go next?
Yeah, I was just asking to go next whenever
we
move on.
Before we move on, anything for Spencer? All right, Jay, you're up. I keep calling you Jay because I don't know what the J stands for.
Yeah, sorry. So I'm Merrick from 7028, and sorry, this is going to be my first time figuring out how to present. Okay. I'm a sophomore. I joined robotics last year. And can you guys see my screen?
Not yet. You might have to say, you may have to pick your monitor and say share. Okay. So it's a little arrow up screen share icon on the bottom, but then I forget. So you got to either pick your tab of your browser or the window, or choose your entire screen. Do you see that? And then hit the confirm the share.
Okay. Good.
No, not yet, but it might be coming because sometimes it takes a second. Let me ask you this: are you on a Mac?
No.
Okay, because usually with a Mac, if you want to share a different window than what you're currently in,
can you help me share quick? Trying to figure out. Sorry, guys.
That's all right.
Can just
While you're figuring out the sharing, do you want to just talk a little bit about your CADing season since you guys did a rebuild as well?
Sure. Yeah. So our CAD looks pretty similar to KnightKrawler in that we built it. Thanks. Okay. So we built a turret first, and then we built a drum as a rebuild. We also are very similar in that we used a one document system last year, and then switched to a multi-document system this year, top down. We have 4 main cadders, so we divide them into subsystems mainly. I'll open our master geometry. Okay, so this is our second robot. I guess I can also go to our first robot. Our first robot was actually like done right, let's say. Our second one was very quickly half done. We were also behind KnightKrawler in that. Well, thank you for sharing all those things, because I'm definitely going to be implementing like Origin Cube and Robot Manager app. That's going to be really nice. But so yeah, we do main geometry, and then we derive from that. But we had been using the create version and then update it from there, stuff like that. So we start with that, then we move into other documents. We weight all of our parts. That's really important to us. And then we're working on systems to improve manufacturing. This is our first year that we had a CNC that was able to cut aluminum. So we were working through that this year too. Yeah, okay, that's my brief overview. Any questions right now?
So if I heard you right, you said you had 4 primary CAD students and you divide them by subsystems. Is that right?
Yep. Yeah, we had like 4 main ones and then 2 learning CADers.
Okay.
How do you make your parts without the Origin Cube?
It's not great. We definitely will be implementing the Origin Cube. We start with master geometry. Obviously, export that master geometry to a part studio, and then from there we'll make things directly off that main geometry, but then mate them all together in that studio, so no rigid assemblies, I guess. And then once we put them into the assembly and have them mated, when we put them into that main, or when we put them in the top assembly, we just mate it to other things in that assembly, not the origin. So not as good, definitely learning. I was also the main one pushing for this top-down system, so it's getting there, but definitely not amazing yet. So. Okay. Yeah. So for those of you that don't know, we rebuilt after week 2. Started entirely new. We brought our drivetrain over. We didn't bring anything else over, and then we just copied a lot from cheap Delphi threads and pictures of cheesy proofs, really. So that was a tough few weeks, but yeah. And shout out to Ricori for helping us. They did a presentation in St. Cloud at the Jumpstart training, and that's how we figured out a lot of the top-down system that we're using today. So that's all I got, other than answering any questions.
Anybody got a question here?
Yeah, I'm just wondering, like, in terms of like general complexity? Like I know you said that your rebuild, the CAD wasn't done right, you phrased it, but did you find that this big dumper style of robot was an easier CAD than the earlier turret style?
For sure. The earlier turret style definitely had the complexity of, I describe it as more three-dimensional. The dumper style definitely like almost 2D in the sense of it's the same all the way through, if you know what I'm saying. Um, Nightcrawler probably had a pretty similar experience. Really, really nice CAD. Nightcrawler, that looked really good. As I know how hard it is to rebuild the CAD halfway through the season.
Yeah, I'll add on to that too. It was one of the main reasons why we decided to do like a full rebuild like that was because we thought the CAD would be a lot easier.
Yeah.
Yeah, it's
Same.
it's pretty much a 2D robot, right?
Yes.
All right. It's 8:30,
Thank you.
but we will keep going. Anyone else want to share anything?
I
Okay.
was just curious, by any chance, do you know, is Ricori's top-down presentation from Jumpstart recorded? Is that part of docked on YouTube?
It might be. I think Jumpstart has its own YouTube channel, I think. And I believe it would be on there if it is out there. Otherwise, Daniel's amazing to talk to. And
Yeah, and Daniel obviously will help whoever out, but I was just curious, just so everyone has access to it, if we could find the link. Maybe I'll search for it, see if I can post it. If I can find it.
Thank you. Yeah.
Kevin, didn't you share a presentation with me from Champs a few years back? That was recorded.
Yeah, there's a ton of like just top down. I could find them and share them, but I kind of got my understanding of how top down works through like 3 different presentations. I could link.
Okay, see what you can find there, and then I'll try to make sure I capture them all and then put them in the show notes as well. Okay, who's up next? All right, Wiley, it's all you.
All right, can you hear me?
Yep, we can hear you. Let's see if we can get your screen share to work.
All right, so
it's working.
This is our CAD from this year. I'm from 2847. I'm a senior on the team. I learned CAD probably around like the 6-week mark last season, or I started learning, went through the FRC design course. And this is the first year where we've really implemented some more top-down design and doing everything off of master sketches in one document and then branching off into other documents. This is the very first year that we have done block CAD, which is why it's in a pretty rough condition, I'd say. And so, yeah, I'm kind of the main CADder on the team. There was one other CADder that did the intake as a subsystem, but everything else was really done by me. So, yeah, I'm glad that we went with the shooter or the drum architecture. Having it's a lot easier to CAD, as you guys said before, with it mainly being 2D. And we originally had plans to climb. We had L3 plans, but that kind of got buried with us chasing the ability to up our balls per second. So our climbing mechanism would be this kind of main chariot comes down and then clamps and then up on clamps. I spent probably about a month on this trying to get it to work, doing a lot of the manufacturing and prototyping myself, and just couldn't get it to work. About a month in, kind of had an L1 climber, and we were like, sure, we'll just run with it. And I mean, yeah.
Wiley, how much CADing had you done prior to this year?
Not much. I did a little bit over the summer. CADed a belt elevator, and then other than that, I really haven't done much beyond this season.
I'm sensing a theme here that primary catters are learning how to cat over the summer.
Yeah, it's a good time to learn, especially when you don't have deadlines such as your week 1 competition or having a bot together. You can kind of just CAD something up and put it together and see what happens.
Do you feel like CADing without actually building anything reduces motivation, or do you feel like you don't need to build anything to be able to just plow through and keep CADing all summer?
I think that it's definitely possible to just kind of plow through and CAD all summer, learn how to CAD different subsystems, but it's definitely rewarding to see something that you've CADed and maybe even manufactured and built yourself come to life when it's finally all built together and working.
That's good feedback. Thanks to everyone who's posting links in the chat. I'm going to try to capture all of these so that I can post them in the show notes. So any questions here for Wiley before we move on?
Wiley, I was going to suggest, could you show the using the origin cube to do the center distance for belts? You taught me that this year and it changed my life. So
yeah. So if I go to the shooter here, it might be in the master sketches here. One of the really nifty things about the origin cube and that whole feature script is the ability to basically put in like your 2 pulley distances or your 2 pulleys and then what belt you want based off of the distance that you kind of want the generalization for. And so you can see kind of like you can get the center to center distance for that belt from using the feature script of the origin cube. And that helps with prototyping because you can really just type in a couple different belts and pulleys, and that can change ratios for you as easy as just implementing a couple numbers and then sending out a prototype.
How do you determine like your belt tolerances? So like for us, especially in the past, we've experienced a lot of issues where we don't have the belt tolerance that are like just right, or it's too taut because it's exact, right? So you have to tolerance it in. So you give the belt a little bit of slack so you could get around those shafts. We ended up using this tolerance sheet that we found online. That's from somebody. I'll link it in the chat right now. But I was just wondering if you guys had anything similar.
Not really. Typically our tolerances, I took inspiration off of some CAD that we had last year and took the tolerances based off of that. And that really helped with being able to put belts on pulleys without having to take both pulleys off and put them on at once.
I think we're still probably experimenting with it. I feel like if your belt's over like 150 teeth, no tolerance has kind of been the move, and under that, it kind of varies, I guess, in the mechanism. But I know before Wiley was probably doing CAD, we ran into some issues for sure doing adding some tolerance in on long runs, belt runs, because they just have enough flex in them where they can pop off really easily too. I don't know if we have it down to a science, Wiley. Do we? What do you think?
I don't really think we do.
All right. Thanks, Wiley. Any final questions for Wiley?
Sam and Wiley, do you want to just explain a little bit on your process of teaching CAD? I mean, it's been nice hearing different perspectives on how kids learn it, I guess. What has been, Megahertz's method?
I guess in my experience, it was kind of just, I saw the fact that our main cadder last year, who had about 2 seasons of experience, and the fact that he was going to be gone for this season kind of gave me the initiative to step up and start learning it. And during the duration of some of last season, over the summer, and then before this season has started, we've tried to and it hasn't been too successful, but get people to basically learn CAD, learn like the very basics of it, and have them implement that into something smaller. So like our drive-based CAD, we had like one or two students who kind of knew CAD, like stepped in and did some of the changes on those whenever we had the main architecture done. And so I guess we haven't had that much success in which teaching people to learn more CAD in the preseason and more pushed it in that November to December range, or right when we're in the midst of our season, trying to teach people CAD when we typically wouldn't have practices.
Yeah, I'll just throw in, we definitely don't have it down to an art or anything, or a science or anything really. I guess a couple of my experiences, like first year students, it's not the best fit. It's really nice if they've like built a robot before, or honestly, we feel like we've had a good experience with like, especially running like our CNC machines and the laser and the 3D printers, just getting them used to going into the CAD and pulling files, how to navigate around, how to hide and show things. The other thing Wiley knows I'm on him for is like having your most experienced students try to set aside like simple tasks. It can be really easy and satisfying to do the simple ones, especially when you're like overloaded with building the whole bot, but trying to get your most experienced students focused on the hard problems and setting aside the easy ones for newer students. And then they feel like they contribute, and you get that flywheel going a little bit of like, hey, I went through, I contributed to some important stuff. It was 3D printed. It's on the robot now. That's awesome. You know, I know you probably had that experience last year, Wiley, with the magnets for our climb.
Yeah.
But that's all the words of, I don't know, wisdom I have, I guess.
Okay. Anything else? Do we have anyone left? Is that everybody? Was there anyone who had said? Oh, Nathan. All right, Nathan, you're up.
Hey, can you guys hear me?
Yep.
Alrighty, let me share this tab. So this was our students' CAD from this year. We had 5 students working on it, and one of them was super dedicated and did most of this top level assembly. So yeah, we had most of the CAD done within 2 weeks-ish. There was a few things that got added and changed later, but the majority of it was done early on. So yeah.
Nathan, do you have any advice on how you were able to get 5 students to work together in a SolidWorks document?
We use Fusion, but it's a similar
Fusion, sorry.
issue.
Yeah, Fusion.
It was mostly broken down by subassembly, and then, like I said, one main student was the one that was actually putting everything together in the top level. And there's no origin cube or anything, so it's all jointed to the actual mounting holes as it would go for the most part.
Now, Fusion does have online parts, right?
Correct. Yeah, there's a team, I think they call it.
Mm-hmm. And so you had students working individually on parts, and then because there is the online component of building online or uploading your step file or whatever it might be, then you were able to have a primary document that was bringing in those parts. Is that right?
Yeah, and give me a second here, and I will try and share the team instead. So this is what the online document or structure looks like, and then if someone's in a file, it'll lock out anyone else from editing that file.
So interesting. I didn't know that.
Yeah,
I've only used Fusion for running my CNC. I've not used it to actually do design stuff. I didn't realize it would lock documents. That's interesting.
Yeah, it's nice, but then if someone's in it and they are not actually editing it, that becomes an issue. So.
Yeah, along with like what Scott said, do you guys use the manufacturing part of Fusion?
This was our first year using it. And yeah, the tech ed teacher uses Fusion for his CNC router and CNC mills and whatnot. And this was our first year using that, and it went better than I think we used VCarve in the past. But yeah, we didn't have any major issues with it.
How do you find the integration from it? I was reading a thread, Team 5000. They use Fusion, and like one of the biggest reasons why they decided to use Fusion over OnShape was, well, the main cadder learned CAD in Fusion, so that's a reason. But also, they found the integration between like manufacturing and like part making really seamless.
Yeah, it was definitely pretty nice because you could pull in your straight Fusion file and then make the tool paths and everything and then export it with that tool for the machine. And yeah, that went, and you could simulate everything too to make sure that it theoretically wouldn't crash on you.
Yep, I think the manufacturing interface in Fusion is pretty good. We're obviously uploading step files into Fusion and then laying them out to be cut. So it is a whole nother step from OnShape to Fusion. But yeah, I could definitely see the appeal of just doing everything in Fusions to support your fabrication.
Yeah, Ben could speak more to this, but over the past year, we built like kind of our method of getting parts to Fusion, and it involves making a separate manufacturing document, deriving parts into that document, putting it in assembly, laying it out the way you want it, importing it into Fusion, and then setting up toolpaths.
Yeah, and ours, we had a different team. So you would download the Fusion file and then re-upload it to the team and put the spoiler board and everything in there. And then pull the correct tool, make the tool paths. We did have a couple times where we had to edit the parts, which was really nice because it was just a Fusion file. So you could just edit the feature and then just go on from there.
Yeah, that is a problem, like Kevin said, when you're using two separate software. I'm guessing it'd be the same if you're using something like Mastercam. Anytime you import a file into Fusion to do the cam or whatever your cam software, and they make a change in your CNC or not your CAD software, you have to re-import the step file and all your changes are gone. So there's definitely, I can see the advantages.
Okay, is there anyone left? Thank you, Nathan.
Yep.
Is that everybody? We ran really late, but I think it was definitely worth it. This was really fun. I really enjoyed everybody who shared their CAD, so thank you for doing that. I'm not going to stretch this out any longer than we need to here. I have one quick announcement. The roundtable is going to be off for a bit. Everyone's going to be traveling back from Champs next week. I'm not going to make anyone suffer through a 7 to 8:30 call after having flown or taken a bus back from Champs next week. And the week after that's Mother's Day. So take your moms out to dinner. Do not jump on the roundtable and instead do something nice for your mom that week. So we won't be meeting next week for Champs. We won't be meeting the week after that because it'll be Mother's Day. I think we're returning back on the 17th, according to my schedule here. And the topic that we are going to have on the 17th will be led by a nonprofit attorney, and she is going to share with us her best tips and advice on how to start a booster club or a nonprofit 501c3 to support your robotics team. I'm very much looking forward to that. I think that we're all going to learn a lot, and I'm going to find out all the things that we're doing wrong for KnightKrawler that we need to do better. But I look forward to it, and I think it's going to be a great roundtable. So look forward to that. We've got 2 weeks to prepare because we'll be off for those 2 weeks. And when we come back, it'll be all about legal stuff for a booster club. All right. Again, thank you so much to everybody that presented tonight. This was really, really fun. I really enjoyed it. I think we've all learned something tonight, and I really appreciate those who shared their tips and asked great questions. So once again, thanks to Kevin. Kevin, you did a great job kicking us off tonight and giving that presentation. And I hope to see everyone on May 17th. Have a great night, everyone.
That's it for this week's FRC Roundtable. Join us live all season long, every Sunday night. Visit the website at team2052.com/roundtable to sign up for weekly invites. In the meantime, keep building, keep learning, and we'll see you next week.